Good morning. This is our first snow day of this school year. And so I don't have any students here in my learning center. So I went to Duncan already this morning. Ta-da! It's right behind my house. It's walking distance from my house to Duncan and then to school, even in the snow and sleet. And so I'm enjoying my day off and I'm going to spend it with you. Aren't you lucky? So the first thing we're going to do is talk a little bit about Physical Science 11-12. Okay, this is the 4th edition PACE. Doesn't that look pretty? And my observation, now you guys haven't had to do the 3rd edition, so you don't have anything to compare it to. But the 4th edition checkups and self-test and PACE test are much better written. And I think students are going to find much more success. And truly, there's a lot of content in the PACE that kind of introduces you to concepts that you're going to hit again when you get to chemistry. But in physical science, they're not expecting you to master it. So the tests focus more on some terminology and some basic things. But for instance, I well remember that this PACE used to have students having to balance equations on the self-test and the PACE test. And it really gave a lot of trouble to students. And they handled it better when they got to chemistry. But anyways, you don't have that on this test. Yay! I'm going to give you a tip for the PACE test, okay? Hang on. But let's talk about what this PACE covers, okay? It's going to cover valence electrons versus oxidation numbers. And I'm not going to do a whole video on this unless some of you find this confusing and you want to send me a message and ask me to go into more depth explaining it. I think the PACE covers it pretty well. The valence electrons basically just means how many electrons are in the outer shell of that element, okay? And we can tell that by looking at the periodic table. The oxidation number indicates whether that element tends to gain electrons when it is in a reaction with another element to form a compound. Is it gaining electrons? In which case, it's going to have more electrons than protons, and so it's going to have a net negative charge, okay? On the other hand, some of the elements, especially in the metals and over on the far left of your periodic table, those elements only have 1 or 2 or 3 electrons, and they're very willing to get rid of those electrons. And so if they get rid of their electrons, their next energy level below that is full, and so then they're happy. We call that octet rule, remember? They're happy if they have a full outer shell. So they will get rid of electrons, and that gives them a positive number. They have more protons than electrons. Okay, so basically every element in column 1 on your periodic table, it's a metal, its oxidation number is positive 1 because all it wants to do is get rid of 1 electron. The elements way over on the far right, other than the nobles, they're already happy, but the column 7, they already have 7 electrons, so they only need 1 more, and if they gain 1 electron, then they have 8. So their oxidation numbers are all -1 because when they gain that 1 electron, they have a charge of -1. But in the middle is where it gets kind of confusing. There are some elements that might sometimes give up 2 electrons, sometimes 3, sometimes 4, sometimes even want to gain some electrons. And so there's a table, and you're not going to have to memorize it. You just have to know that's what it means. If it's a positive number, that means it gave up that number of electrons. If it's a negative number, it just means in a reaction with another element, it tends to gain that number of electrons. That's all it means, okay? So now that you kind of know that introduction, go ahead and study that section, see how you do on that checkup. We're going to learn a lot more about the periodic table. And in the next couple of PACEs, we're going to dive deep on all of the elements. So I would suggest, I'll mention this again later, but if you have a smartphone and you're allowed to download apps, do a search for some periodic table apps. And they often have a lot of information, more than the PACEs have, and you can dig deep and learn some interesting things about the elements. But it was structured in a very interesting way that's helpful to chemists, right? Then let's talk briefly about covalent versus ionic bonds. So covalent, let me start with ionic. I got a sip of coffee here. Decaf, because it's, I already had 2 cups of regular coffee. Ion, the root word of ionic is ion. And an ion is an element that has gained or lost electrons. Remember that? If it has lost electrons, okay, then it becomes a positive ion. Technically, they're called cation. Are you positive about cats? Do you like cats? If you're positive about cats, it'll help you remember that the positive ions are cations. And then the negative ions, you remember, are the anions. A negative ion is an anion. But if you have opposite charges, positive and negative, boom, they attract each other. Sodium gives off 1 electron. Chlorine gains 1 electron. Boom, opposite charges attract those 2 together, and it's a strong ionic bond. Okay? Basically, it's always a metal and a nonmetal to be ionic. Covalent, okay, the root word here, valent, means the valence electrons, but instead of completely gaining or losing electrons, they share, okay, they are covalent, so they share electrons, and they're grabbing onto each other and holding on and not letting go and taking advantage of the other elements' electrons while holding on to their own, okay? So, interesting point that your PACE will make is that all the covalent bonds are between nonmetals, okay? So if it's only nonmetals, like carbon and oxygen, carbon dioxide, carbon monoxide, and those only form with nonmetals, but they're sharing their electrons. And then there's differences in how these compounds are named besides how they're formed. And so you'll read about that and study that in the PACE, okay? And then the last section of the PACE is different types of of reactions. So there's things being put together to be formed, like you can put hydrogen and oxygen together, and obviously it forms H2O, water. You could go the other way and break it apart. We call that decomposition, where you could take a compound, break it up into the things that made it up. You could burn something, all right? We call that combustion. There's always oxygen if you burn it. And then there's, I think, carbon dioxide and water are the products when you have a combustion reaction. There's some reactions where if you put 2 things together, one of them will kind of like kick the element out of the other compound and take its place. And so we call that substitution. Anyways, you'll read about that. Those are not too hard. And like I said, the PACE tests are a lot easier than they were back in the 3rd edition. So you are lucky, okay? Now, I have not gotten any feedback yet from students who've gone through PACE 11, 12 that they've had anything they need me to explain. But if you need help and you think, I think other students would benefit from a video explaining such and such, let me know. Go to my website. You can leave a comment on the video itself on YouTube. I do check those periodically, and we'll see what we can do. The one tip I will give you, are you ready? This is not cheating because I'm showing you what's on the self-test. You already have this PACE test in front of you. On the self-test, there is this chart showing the sections of the periodic table, right? And then you have to name those sections in this column here. Guess what? That exact same chart is on the PACE test. So it would behoove you, that's a good word, huh? To study that. And it is worth 20 points on the PACE test. All right, so it's just, do some practice with that section. Make sure you know that. Make sure you know the terminology on the checkups, and I think you will do well on this PACE.